Okay, so I'm going to be recording this part of the session, and just so it's recorded, very quickly again. Okay, just very quickly again, and just so it's in the recording, the due date for stage 2 has been, we pushed that back to May 4th. Basically, what we're going to be doing is we're going to be finishing up the development part of the development part when we come back from spring break, and then we're going to start the lab exercises with Microsoft Access. So the topics that you're going to need for the stage 2 design, we're going to finish covering those up before we finish April. And then for stage 3, which is actually the development, we are going to be working on Access, and we're going to be taking the end of April and most of May to do the lab exercise. So just take note of this change in this due date. Okay. And I'm just going to jump over here to the PowerPoint. I asked you guys to work on the gym fitness problem. And so in the gym fitness database, we were basing ourselves on this ER diagram. And what I asked you to do is to create the relational model. Okay. And the relational model is basically going to be the tables we're going to be using to implement in the databases. And I think you've noticed, I was seeing what everybody was doing, and everybody was on the right track. Basically, it's really simple. We're going to create a table for each of the entities. So in this case, we would have 1, 2, 3, 4, 5, 6 basic tables, which is the member table, the membership table, a one-day pass table, a pass category table, a sales transaction table, and a merchandise table. Those would be the 6 tables that come out of the entity relationship diagram. And in those tables, we're going to identify which relationships are one-to-one, one-to-n, and n-to-n, or one-to-one, one-to-many, or many-to-many. In the case of the one-to-one relationships, we're just going to grab the primary key of one of the tables and put it in the other one. In the case of the one-to-n tables, we're going to grab the primary key of the one and put it in the end. Okay. And in the case of the n-to-m relationships, we're going to create a new table. So here for this diagram, we have 1, 2, 3 relationships that are 1-to-n, 1 relationship that is 1-to-1, and we have 1 relationship that's many-to-many. Of this relationship that's many-to-many, we create a new table. And that table is going to have both of the primary keys of the original tables. So in total, we should have 7 tables in the relational model. That's basically what you guys did last class. If we look at an example of the relational model here, we have the 7 tables. We notice how the primary keys are included into the additional tables depending on the relationship. So for example, in the membership table and member table, this was a 1-to-1 relationship. So we grab the member ID and put it on the member table, and that relates those two. Then we have the member and sales transaction. Okay. That was a 1-to-n, so we're grabbing the member ID and adding it to the sales transaction table. We had the member and one-day pass. So a member could buy a one-day pass. That was a 1-to-n as well, so we grab the member ID and put it here. We had the pass category in the one-day pass. This was also a 1-to-n, so we grab the category ID and put it in the one-day pass table. Then we had the merchandise in the transaction. That was the many-to-many. And so since it was a many-to-many, we needed to create a new table. In this case, the table, well, by the way, when we're gonna name, that was a thing that I noticed that created a little bit of confusion. When we're gonna create the new table, what are we gonna call the new table? We can call the new table however we want. One thing that's being done here is that the new table is called the name of the relationship that joins those two. So that's why it's called sold via, because the merchandise is sold via a sales transaction. And this new table combines both of the primary keys into one new composite primary keys and adds other things that we might be interested in. In that case, the number of items that were sold via the transaction. And that would be an example of the relational model or relational scheme. One thing that I asked you to do that isn't reflected in this solution, I asked you to define a nomenclature for the attributes. Right? And each of you define a nomenclature in a table that sets the attribute and explains what the attribute is or gives a description. We're going to be doing that for all of the examples exercises that we're going to be doing from now on, as well as for your application. Questions with this one? So this solution is already in the PowerPoint. It's already up there. Okay. So what you're going to do now is that we're going to be doing one more exercise that kind of tries to wrap everything up. And this is going to be an exercise for FlixNets. FlixNets is a TV company. By the way, I was reading this example, and something that's going to come up when you're solving the problem. I was reading this example, and the example is from an older text. Doesn't really matter that it's from an older text. The exercise still serves its purpose. But there's a little detail here in the description of the problem that you're going to have to consider that I believe is a detail that's dated, that you guys are too young to understand that, because you're used to programs that are on demand, right? And programs that are streaming whenever you want, right? So if you want to see a TV series, you mentioned you were watching the TV series, right? So you can watch the whole series or any episode you want whenever you want, right? Except some limited series that come out an episode a week, like some of the ones that are coming out of Disney Plus, like Moon Knight, for example, just started last. Did I see that one? It's pretty cool. We saw it a couple of days ago. I really like. We have no idea what the character is about. I have no idea, no background. But I found the episode interesting, and it's a little bit weirder than what we're used to from Marvel, and a little bit spooky, and I kind of like it. But the next episode is going to come out next week at a certain time. Well, actually, not at a certain time. The episodes are available at midnight, and depending on your time zone, you can see them. But after that, both episodes are available, and all episodes are available. So you guys are used to that, right? In the past, when people like myself were young and watching TV, it was a bit different. So, the show is Bridgerton, right? Okay. So imagine that you're a really, really big fan of that show. You're a really huge fan of that show. And there's something very interesting happening on the show, and you want to watch the next episode. So before, the way it happened is that episodes had a schedule. So episodes of Bridgerton would be, I don't know, Wednesdays at 7 p.m. And that's the day and time you would watch the episode. And if you didn't watch the episode on Wednesday at 7 p.m., then you didn't watch the episode. There was no way for you to log on to a web page and download the episode or stream it. You had to watch it in the day, and if you didn't watch it that day, you would have to wait for what was called a rerun. And a rerun was when the broadcasting company suddenly said, you know what, we're gonna air the whole season of Bridgerton again beginning this date. But it was in a specific date and time that you had to see the episode. That's not very common right now because of more of the on-demand and streaming service. So we're thinking about a TV company that's called FlixNets. And similar to Netflix and Disney Plus and HBO Max and et cetera, Paramount Plus, these companies are developing their own shows. And actually the success of these companies is largely depending on this new content that they're developing. So FlixNets wants a database to store the data of the TV series that the company produces. Not necessarily the ones that are bought from other licenses, but the ones that they produce. What information do we have? The actors that who play in the series, the directors who direct the episodes, and the episodes and series themselves. The actors and directors that participate, those are employed by the company. I don't know if you've noticed that, I don't know, Netflix, HBO Max, Disney Plus, they have their own series, and suddenly a lot of actors appear in the same series. Like, for example, for Moon Knight, you've got Oscar Isaacs, which appears in the Star Wars series as well. There's certain actors that the company has to have contracts. And they have certain directors that they have contracts with as well. Like Disney, they probably have some sort of contract with like he's directed a bunch of Marvel things, Star Wars things. And he suddenly appears in some episodes as a director. So actors and directors are employed by the company. The TV series are divided in episodes. Okay. Oh, this is what I was mentioning. Each episode may be transmitted at several occasions or at several times. An actor is hired to participate in a series, but may participate in many series or more than one series. Each episode of a series is directed by only one director, but different episodes may be directed by different directors. So the whole series doesn't necessarily have to be directed by one director. What are things that we would like to extract from the database? Which actors play in a particular series instead of Big Sister, substitute that for Bridget. In which series does the actor instead of Bertel Baum, let's say Oscar Isaacs, participate? Which actors participate in more than one series? How many times has the first episode of a series, a particular series, been transmitted? And at what times? How many directors are employed by the company? Which director has directed the greatest number of episodes? Okay. So what I want you guys to do based on this information is to identify the entities, attributes, and relationships, create the ER diagram, and create the relation, which basically is doing everything we learned how to do up to this point. And the idea is for you guys to work in houses and turn it into real life. Now, before you begin to work, let's do an exercise to try to identify some of the entities that we've got. Can somebody tell me? And let's write them. Let's write them down here, just to. And I'm gonna be, well, no, let me do this. Whoops. I don't want to bring out my tablet, so I'm gonna write them down here. Let's do a quick exercise here where we identify the entities. Moment. Just to kind of start out with the same baseline. Okay. Okay. So let's start identifying the entities. Can somebody tell me? Just let's start. Shoot it out. What can somebody tell me an example? Or what could be an entity here in this for this situation or problem? Yeah. The actors, correct. So actors is going to be an entity, correct. Another one, Marco. Directors, correct, that's gonna be another entity. Episodes, correct, that's gonna be another entity. Okay, what else? The series, correct. Well done, actors, directors, episodes, series.
Members?
Members, in what sense?
Like, for the subscription.
Oh, the TV company, we're gonna assume that it has members like Netflix, Disney Plus, etc. But again, remember what we talked about relating to the scope of the problem. So yes, the TV company is gonna have members, but right now we're not really interested in the membership. We're only focusing on the part of the database that has to do with the information of the episodes.
So what about the censor composers? Like, I don't know which one's gonna be more important.
Regarding the music and who's paying for it. We could also include those. We could also include the
What about
produce.
brands? Brand. Like
Uh-huh.
Marvel, no. So-
Well, that's a good observation. Would the brand necessarily, we could include the brand or the company, the producing company, as an entity. If we wanted to, or we could add that as an attribute in the episode.
Oh,
I'm gonna put it here as an asterisk, okay? This could be a valid entity. Right now, these four are the basic entities we're gonna be. There's one more that we need to add, just because of the particularity of this problem having to do with what I was mentioning. Schedule, exactly. And that's because of what I was mentioning, that the way this is conceptualized is that the episodes are going to air on a certain date or a certain time slot. Okay. And so we're going to call that, for lack of a better term, we could call that schedule. Okay. And a schedule, what would the schedule be? A schedule would have time slots. So there would be a time slot that would include a day and the date and the time, or dates and times. Okay. So I'm gonna write it down this way. I'm gonna say schedule time slots. Okay, time slots. Okay, are we good up to this point? The production company could also be related, because if you notice when you particularly, for example, in Disney Plus, one of the first things that appears in Disney Plus at the beginning is the category. So it says Marvel, it says Star Wars, everything is Disney in the end, but they're kind of coming out of the Pixar, etc. Are we good up to this point? What other things are important here? Let's talk a little bit about the relationships. Okay. What relationships could we identify here between the entities? So, so let's say actors, I'm going to say it this way. I'm going to put it in a smaller letter here. Actors act in episodes. Okay. And I would say that that's correct, because we could also say actors act in series. Well, yeah, but what it's telling us is that we want more specific information, because I could say a particular actor I'm going to give a spoiler for Peacemaker, but I don't think you guys have seen it. So Jason Momoa is Aquaman, right? And so I could say Jason Momoa is an actor of the Peacemaker series. And suddenly, either if you like Aquaman or you like Jason Momoa, you're gonna go wanna watch Peacemaker. But actually, Jason Momoa only appears as Aquaman in a cameo for about 10 seconds in the last episode. Right? So saying Jason Momoa is an actor of the whole series might be misleading. What we want is to say Jason Momoa is an actor in episode 8 of the Peacemaker series. Okay? Just clearing that up because we could also say that actors act in series, but really the episode is what we want. Yes.
You could say that directors lead the series.
Directors what?
Directors lead the series or
Lead. Produce. Well, actually, the part of the directors is similar to the actors because then they're telling us that a director can participate in one episode or many episodes. So, for example, in the Peacemaker series, James Gunn is the producer and the writer, and he directs some of the episodes, but other episodes are directed by somebody else. There are some series where the whole series is directed by one director. So the relationship with directors and directors is very similar to the one with actors. So directors direct episodes. Okay. What other relationships do we have? A series has episodes. And remember that the relationship doesn't have to be a very complicated or has is fine. So a series has episodes. Okay. Which one are we missing there? An episode has a schedule or a time slot. I'm leaving the option of you calling it schedule or time slot, however you wish. Okay. Are we good up to this point? This kind of sets up the relationship. The relationship of actors and episodes, what type of relationship would that be with regards to cardinality? An actor. Okay. Well, let's see. An actor can act in many episodes, right? And an episode can have many actors. And so it would be many to many, right? And I can appear in all of the episodes of the series, and the episode of the series has many actors. Okay. So that would make sense for it to be many to many. What about directors and episodes?
like any
Director, but it depends on how you see it, right? It could be one director for one episode, that's it, or, yeah, director.
Well, that's how we establish the relationship. So a director directs episodes. How many episodes can a director direct? Many. But an episode can be directed by how many directors? Just one. That's the way the problem is established, because in reality, there might be a situation where an episode, a movie, or whatever is co-directed. So, for example, the Infinity War, Endgame, and Civil War were directed by the Coen brothers. It's co-direction. If you like the Matrix movies, it was the Wachowski brothers, which actually aren't brothers, by the way. There might be a co-directing, but right now the co-directing isn't an option, so it would be a one to many. Okay. Series and episodes. How many episodes can a series have? An episode belongs to how many series? One. Okay, so that would be a one to many. Okay. And lastly, an episode in a time slot or schedule. How many time slots or schedules or scheduling can could an episode have? Depending on the time zone, but you kind of answered the question there, no. So that would mean that there would be many. So an episode can be in many time slots or schedule. Could have a. That's why I scheduling is correct, but the word scheduling might come. That's why I'm adding time slots. So an episode can be in more than one schedule or time slot. But a particular time slot, how many episodes can be in that particular time slot? Just one. Okay. So we would have a one-to-many here. Is that clear? We kind of solved about 75% of what I'm asking you to do. So is this clear? I'm going to leave this here on the screen. Get together in houses and work. Basically, what you need to do now is just do the ER diagram and do the relational one. Okay. Upload it to Blackboard before we have the earthquake simulation. No, not before we do the earthquake simulation, but start working on that. And I'm just going to add it here on the bottom. Production company owns series. I'm just adding that there because it was an interesting observation by Andres about the production company. If we wanted to add the production company as part of the information we want, we could say that a production company owns the series, and a production company can own many series. The series is only owned by one production company.